Infrastructure companies are the final gatekeepers of the AI economy. They provide the containment layer required to turn raw intelligence into a safe, production-ready tool. In isolation, a base language model is completely stateless. You send a prompt, you get a response, and the conversation is over. The model forgets you existed the second it finishes typing. A functional agent requires more than a chat interface. It must wake up after a network disconnect, remember what happened yesterday, react to external events, and execute scheduled tasks without a human holding its hand. Deploying an agent without strict boundaries leads to expensive failure patterns. A system may stay entirely inside its permissions, but gets stuck in a loop that drains millions of tokens. It could retrieve confidential customer commitments and leak them to a user who lacks clearance, or confidently process an unauthorized refund. Raw intelligence is actively dangerous if nobody can say what it is allowed to spend or who can stop it. This intelligence requires a specialized infrastructure layer built to govern, contain, and operationalize it. The first requirement for containing an agent is giving it a stable place to exist. This is the runtime layer. To survive a disconnect or pause for human approval, an agent needs a stateful microserver, like a Cloudflare durable object. AWS and Vercel also provide this critical stateful infrastructure, packaging memory, scheduling, and gateways to give agents a reliable operating environment. Even a stable agent creates chaos if its permissions are unclear. A system acting with fuzzy authority, where it is impossible to tell if it is acting for a user, a team, or itself, will trigger security breaches across internal platforms. The identity layer solves this through delegated authority. Instead of permanent credentials, an agent obtains temporary consent to act on behalf of a specific human. Auth0, Okta, and Microsoft Entra are the gatekeepers for this layer. They ensure an agent's permissions do not persist across multiple sessions or extend beyond the scope of the original request. Without persistent runtime memory and airtight identity boundaries, an agent cannot be trusted to operate within a corporate environment. An agent is only as reliable as the data it is allowed to interpret. If it joins the wrong tables or misreads an internal metric, it will confidently present a false assumption as a business fact. This semantic layer acts as a governed perimeter for business truth. Platforms like Snowflake and Databricks enforce this data governance. They restrict the distribution of meaning, ensuring the agent only reasons with a verified pipeline of authorized information. These systems introduce an even higher level of risk when they cross the threshold into financial transactions. Automating payments also automates the potential for disaster. Without heavy oversight, agentic commerce leads to high-speed transaction fraud, unverified merchant onboarding, and an uncontrollable spike in disputes. To mitigate these risks, agents rely on an institutional trust layer. Operators like Stripe, along with major card networks like Visa and MasterCard, provide the regulated rails necessary to authorize autonomous spending. An agent's cognitive capabilities are effectively irrelevant if it lacks the governed infrastructure to interpret private data accurately and execute financial transactions securely. Standard API logging fails to catch the most dangerous agent failures. A log can show that a tool was called with valid syntax, even if the agent used that tool to violate the user's actual intent. LLM observability requires tracing the entire workflow, from the initial goal to the policy permitting the action. Datadog and Langsmith act as operational watchtowers, stitching costs, tool calls, and outcomes into a single view to identify failure patterns in real time. Observation only provides value if you have the power to stop the machine. You need a kill switch. Sending a stop prompt to a model is insufficient. The request may have already reached an external API before the model even processes it. A true kill switch requires a coordinated trapdoor. It must simultaneously cancel the runtime workflow, revoke the identity credentials, and freeze the payment gateway. Comprehensive observability and multi-layered termination protocols are the only barriers preventing an automated workforce from becoming a corporate liability. Every production agent must satisfy 7 constraints: runtime location, identity authorization, data access, tool permissions, spending limits, observability, and termination authority. As this vault door demonstrates, raw power requires heavy mechanical protocols to be safe. Compute capacity will scale and models will improve, but neither factor determines whether an autonomous system is actually allowed into the real world. The companies managing these containment layers are the primary architects of the AI economy. By controlling the gate between intelligence and action, they determine the future of autonomous work.